Okay. I think you can start anytime.
Oh,
I think
okay.
we should go. So
Sounds
whenever
good.
you're ready.
Okay, welcome everyone to our third session of Scratch for Dev Day Yuma. Today we're going to go over a couple different things, namely though, sounds. We're going to briefly just recap on sounds. We touched a little bit on that in the first two sessions. We're going to go over sounds. We're also going to go over cloning, which is going to make up the majority of our game. And then we're also going to go over messaging in the messaging system within Scratch. And that'll all make sense a little bit more when we get into it. But as in our previous sessions, if you weren't able to make one of the previous Hangout sessions where we're actually doing this live, I've muted everybody's microphones. If you have any questions whatsoever, you can type it into the chat box on the right-hand side of the Hangout. So if you move your mouse to the left-hand side of the screen, there's an icon for a blue chat box. That'll pop up a chat window on the right-hand side of the screen. If you're joining us from YouTube Live, we also have the live chat up on the YouTube Live channel, so feel free to ask questions there as well, and I'll jump to them as soon as I get them. So if you're continuing on from last week, we are working on a game that I've affectionately called Space Donuts, because the game is basically Scratch the Cat catching donuts that fall from space, essentially, on whatever moon he's on. So if you've been following us from last week, or you did the YouTube live tutorial afterwards, you should have a game that's pretty much up to here. We get one donut that drops from the sky, and Scratch the Cat is able to move left and right along the screen. So that's where we left off, and that's where we're going to pick up. So our first step is to add a sound. We're going to add a sound effect that when Scratch the Cat catches the donut, he eats it. And if he doesn't catch it, we can either leave it with no sound at all, or maybe even put just like a wah, 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 or, fail horn or something like that. So we're going to start by looking at our logic that we put in last week. So last week's session was on logic and variables. And if we click on the donut and on Scratch, we can see the different scripts that are running for each sprite or each character or object in our game. So Scratch the Cat basically is just his movement script. And then the donut is what actually deals with the logic of whether or not Scratch has caught it and whether or not it's hit the bottom of the screen. So right here, we've already got our if touching Scratch the Cat, change the current score by 1, and then hide the donut. So here's where we're going to put in our first sound effect. And sounds are really easy. They're just found in the middle panel under the sound blocks. And there's a couple different ways that we can put in some sounds. But the easiest way is to use one of these first two blocks, play sound pop, or play sound pop until done. And there's a difference between those two that's really, really important when you get your game running and there's multiple sound effects running. If you decide to put music in the background or anything like that, it's really important to know the difference between the two. And the easiest way to describe that is just that if you have something that repeats a sound. So in this case, let's say we did a pop repeat. And I'll actually put this on here. You guys won't be able to hear it since we're in the Hangout, but if you try this on your own, you'll be able to kind of follow along. A sound effect is able to be played on top of other sound effects. So if we make a loop that says something like what we have here, where it repeats forever, and we put in a sound effect that plays, Scratch is not going to wait until that sound is finished to start the next one. So if you'll remember our very first project that we started off with, where we had Scratch the Cat kind of walk up to the cowbell, that loop basically caused the cowbell to play over and over and over again, but it didn't wait until the first time that it finished. So instead of getting a sound effect, then the sound effect starts over, then it starts over, we get kind of just a wave of whatever the first part of the sound is, because that sound is just playing over and over and over again, but immediately. There's no pause to it. So if I put this pop sound effect here into the forever block, if you played it on your computer, you'd hear it. It would basically just go crazy. You just hear the very first part of that sound effect as it just got repeated over and over and over again, and then eventually it just turns into a mess. Whereas play sound until done waits for the sound to finish playing. So especially if it's music, it will wait for the entire sound effect to finish playing before it continues on to play the next sound effect. So it's just when you start using it, you'll want to play with both of them to see which one gives you the result that you want. Sometimes, especially, you know, once we get to the point where we have multiple bubbles, or sorry, multiple donuts on the screen popping, you'll want that sound effect to overlap, because maybe you've caught 3 of them in a row, or 2 of them at the same time, and you'll want both of those sound effects to play at the same time. So in this case, we're going to use the play sound pop. And if I test this, we should hear that immediately go into effect once we catch the sound. But maybe we'll want to assign a different sound effect to our donut. And that is all done, all sound effects besides the actual logic blocks or the code blocks that cause that block to play. All those happen in this sound block section, but all the actual sound choosing and editing happens in the sounds, in the sounds tab up at the top here. And this is just like the sprites tab, where we have the ability to change the costumes like we talked about very briefly at the beginning. So you have the same options that we have for drawing things or for new characters for sounds. The first icon here is to choose a sound from the library. And this is just all the preset sounds that come with Scratch already. So we can choose, bubbles, and hit the play button to kind of preview it. We're going to be using our chomp sound effect here, which is basically the eating sound effect. So I can play that here if I want. Let's see if maybe we have a clap, something that sounds like we messed up. Maybe a crash. Is there a crash sound effect? Crash cymbal. I don't really see a crash, but we can choose any sound that we want, just something that sounds like we messed up. So I'm going to choose this wub beatbox. So first I'm going to go and choose our chomp sound. Chomp. I'm going to select that so it's highlighted and then hit OK. And that adds that sound to kind of our list of sounds that we can use for the donut object. And then I'm going to go back. So sorry, I did that kind of quickly. I'm going to choose a new sound again. I can also record a sound from my headset. Obviously, I can't do that right now because we're using the headset for the session. But I can also record the sound and also upload from a file that I already have on my computer. So if you want to find some sound effects that you want to use in advance, you can do that, save them to your computer, and then upload those from here. My only reservation or caution about that is just be wary of intellectual property. Does Scratch tell you how long each sound effect is? We got that question in the box. It does once you've added it to your library. So you can see here that this one is 2 seconds long, or actually not 2 seconds long, it's 2 frames long. And this one is 26 frames long. So there's small numbers. They're really hard to see on here because they're kind of tiny. Let's see if I can't zoom in on it. But you can see it underneath the actual sound itself. As far as this window, I think you can hover over some of these. Maybe not. No, okay, so it doesn't tell you in here how long the sound effects are. Like I said, you can play them to preview them so you can hear what they are. But it doesn't tell you until you actually add it to your sound library for that object. So I'm going to do the same thing that I did for the chomp sound. I'm going to click the choose sound from library button, and I'm going to go in and choose maybe a screech. No, that's terrible. Scratch. Oh, that's kind of a nice one. It sounds like something falling in the water. Plunge. Let's see. Oh, I like this one. Squawk. That one's kind of funny. So I'm going to choose squawk and then add it to our project. And now I know that we're not going to use the pop sound effect for right now. So an easy way to manage these is when you highlight each sound effect, you'll get a little X in the upper right-hand corner. That'll just let you remove that from the library. So this way we're only using the sounds that we're actually going to be using in our project. We talked about it a little bit in the beginning sessions about how when you're using stuff, you don't want to leave things that you aren't using in the project, because Scratch actually has to load those things and it's going to slow down the project. So we just want to make sure that we're being as efficient as possible and only including the sound effects or the scripts that we're actually using for this character. So for my donut, I've got the chomp sound effect, the squawk sound effect. And now if I come in here to the script section, I'm going to be able to choose those sounds from this drop down. So play sound chomp, and then I can grab another sound block and put play sound squawk. And then that should basically make it so that when Scratch the cat touches the block, we play the chomp sound effect, we hide it. And then if we miss it, we should get a squawk. And now, if you're following along, one thing that you'll notice is that even though we've hidden the donut here, technically it's still moving. It's just invisible at this point. So back to our previous point about sound effects repeating over and over, once the donut hits the bottom of the screen, this squawk sound effect will start to repeat over and over and over again. We'll fix that in just a little bit, but just if you're following along and that happens to you, that's the reason that that's happening. It's because the donut still exists, it's just hidden. So all the logic is still happening. We just can't see that it's happening, or we can't see the donut, so we don't know that it's being triggered there. So that's our brief introduction to sounds. You can also go in and add a sound effect to Scratch the cat if you want to. If you want to add in some additional logic so that he only plays his sound when he catches the donut or whatever, you're more than welcome to do that. And then another thing that I like to do, I'm not actually going to connect it until the very end of our game, but I like to put in the forever loop a play sound until done. And then I like to choose music that we can use. There's some music loops that are in here that are set up specifically so that they loop over and over again when they're played. So you can kind of listen to some of those and see if there's any that you like. There's actually a dance space song, so I'm going to choose that. And I'm going to get rid of our pop sound effect. And so that way, when I start my game, I'll hear that sound effect play over and over and over again and loop while the game is playing. Change it to dance space. There you go. So now I've got some music playing in my game. Now, for testing purposes, I'm not going to want to leave that in there because I don't want to hear the same song over and over and over again every time that I play this or every time I test it. He should meow after he eats the donut. There you go. You can set up. So if you want to take the logic that we made here for touching on the donut side and add that to Scratch the cat and make him meow when he eats the donut, you'll get a chomp sound effect and a donut, or sorry, and a meow. You can do literally whatever you want. So then our next step, and this is kind of probably the most complicated part of what we're actually going to do for any of this training, and that's working with clones. And clones are really important because for the majority of the things that you do in Scratch, whether it's video game projects or even just application projects, I mentioned that we had worked with another group on like a paint program. And that happens all the time where you'll have kind of, rather than a game, more of an app type scenario. And one of the things that you'll notice as you kind of work with this is that you start to reuse things over and over again. So in this case, we have a donut here that falls, and our game is not much of a game if only one donut falls. We want donuts to fall from everywhere. I mean, obviously we want to space them out a little bit, but we want donuts to fall you know, forever and ever and ever until we either lose the game, which we'll need to set up some conditions for how to actually lose the game, or just go, you know, on perpetuity like Tetris until you hit a high score, or you know, you can essentially go on till infinity. Our high score could keep going on forever. So a couple different ways that we can do this are, one, we can go to each donut here and we can duplicate it. And since the logic is the same on both of these donuts, every time we start the game, they'll start off in two different places, but they'll start off at the exact same time, and they follow exactly the same logic. So they all kind of fall at the same speed, at the same place. Everything is exactly the same about them. The only thing that's different is our random start position that we set up here. So that doesn't really make for much of a game, but at the very least now we have a high score that, you know, we could move in. So we're not going to use that method though, because then to make our game interesting, we would have to duplicate this, you know, an infinite number of times, however long we wanted the game to go. And then we need to change the logic, you know, to put in a delay so that all the donuts don't fall at the same time, so that they kind of fall. And we can do that. We can have a random number, you know, that cycles, and then make another forever loop that is up here at the top of our code that doesn't start it until something happens. But the easier way to do it is with clones. And clones essentially, so first thing I'm going to do is delete our extra donut. I only need one donut. And clones essentially are a way inside of Scratch to just create copies of something that we already have. Okay, and those blocks are under the control section down here at the bottom. And there's 3 that apply to cloning, and we'll use all 3 of them to kind of set up the logic for our game. So our first one is called when I start as a clone. And just like it sounds, this only happens when our item, it doesn't happen when the game starts. So it essentially replaces this when green flag clicked item. And instead it says when I start as a clone. So essentially when I'm created, when I'm added to the game. Okay, and you may think that it's added right here. It's already in the game. It's right here. But clones aren't added until this block is used. Create clone of blank. And you can do create clone of myself, or you can actually choose another object to create a clone of. Okay, so this block needs to come in first. And then when this block happens, anything that uses this block triggers. That's the event that gets triggered. Does that make sense to everybody? Can I get a thumbs up if that makes sense? Or a message in the chat window just to make sure we're following along? Okay, perfect. So the first thing we need to do is get these donuts to actually be created. And there's a couple different ways, like we've talked about. There's multiple ways to do everything. But in this case, I think the easiest way to do this is to have our stage generate our donuts. Okay, so we have a forever loop here that runs and says, you know, if the high score is greater than, or sorry, the current score is greater than a high score, then do some things, and then otherwise create a clone of the donut. So this loop right here is already keeping track of something else. Okay, so what I'm going to do is I'm going to create almost like a duplicate of it, but not quite, where this is just going to loop forever as well. It's going to create a clone of our donut. So as it goes, it's going to keep creating donuts over and over and over again. But then it's going to wait 1 second in between donuts. Okay. And the reason we're doing this is so that when we start our game, there's a delay in between donuts. And if you want to get crazy and do some kind of unique stuff, Miguel, I see you're kind of. We'll circle back so that you can kind of see exactly how this works when we start the game. But I'll do a little bit of a recap. Hopefully that will make a little bit more sense. But what our logic here says is that when I click this green flag, this loop is going to happen forever, and it's going to make one of our donuts. Okay, and then when our donut kind of appears on the screen, we're going to wait 1 second. And I started saying, if you want to get crazy, you can put some other operators in here. If you want it to randomly wait a certain number of seconds, this is a changeable value. We can change that to whatever we want. So if you want to make it go slower, you can do 10 seconds, you can do 2 seconds. You can put in a random value there. Later on, maybe you want your game to speed up the farther you get. So you could put in a variable amount that increments every couple seconds. But in this case, we're just going to do 1 second. We're going to make it really simple and just have it wait 1 second. So now if I start my game, what's going to happen is a donut is going to be created every second. Okay, so I'm literally cloning my existing donut every second. Okay, now one thing that you'll notice is that all that's happening is that the donuts are being cloned at their exact position. Okay, so imagine that every single time this create clone item happens, we duplicate this donut. Okay, so that's essentially what's happening, is every single time this block fires, we're making a copy of our donut at its whatever it's doing at that moment. It's being copied at that moment. Okay, so in this case, it's following this logic and it gets created or copied. But then you might notice that as we start this, why aren't these donuts also falling? Okay, and the reason for that is simply that last block, or sorry, the second block, this when I start as clone block. So clones do not take the behavior of the original item. Okay, they are copies of the original item, but they don't act the same way as the original item. And what I mean by that is just when I create those copies, they're not following these instructions. And the reason they're not following those instructions is because at the time that those clones are made, we are not clicking the green flag. We already clicked it. We clicked it when the game started. So when these guys show up, we're not clicking the green flag. If we did, then we would see them start falling, but the green flag also restarts our game. So we technically would never see that happen. So what we want to do is add this when I start as clone block, and we want to move it, all of our logic, to the clone section. Okay, so all we did is we took the logic that we already set up, we already made this happen, and we just move it into the when I start as clone block. Okay, does that make sense to everybody? So what's going to happen now is when we actually start the game and those clones start to appear, every time they appear, now they're going to follow the logic that we originally had. Okay, so let's test that out, and we'll see some issues, but you'll kind of get the gist of it right away. So already, it's waiting 1 second because of our logic here. It's waiting 1 second and then creating a clone, and then each of the clones follows their own logic as it goes. Okay? So one problem that you might see, obviously, is that our donut now, because we removed all the logic for our first donut, that it's just kind of sitting there floating in space doing nothing. Okay, and a really simple way to deal with that is just to use our hide block so that when we start the game, that donut gets hidden right away. I also like to reset its position so that it goes to the top of the screen. So we'll put 0 there, and our top position is 180. So again, we won't ever see this happen because we've hidden the block, but now when we start the game, our donut disappears and only our falling donuts show up. At the very least, now we kind of have a game going. It's not a very interesting or fun game.
Well, I was going to say, Derek, in the interest of good game design or challenging game design, if Scratch the Cat has a whole bunch of donuts to choose from, he's not going to have very much trouble catching one.
Right.
So presumably you're going to make it so that now he's trying to avoid them or something like that, right? To make the game
Similar. So what's going to
yeah.
happen well, as we kind of work on the game and start using messages, which we're going to talk about in just a little bit, the game is actually going to go faster and faster and faster. So
Okay.
as it goes on, he's going to have a harder time catching the donuts just by virtue of that. But we don't have any of that timer set up or anything like that. So we'll talk about that in just a second. But just in the interest of following our logic and making sure that it's working the way that we kind of intended to, you'll notice that our high score works. So that value is saved. The last time I caught 12 donuts. And then you may also notice that it updates. But if you're following along, one of the things that you definitely will notice, because it's kind of been playing in my ear this whole time, is that our sound effect starts to loop over and over and over and over again. Because as I mentioned, if we remove these hide blocks, what you'll see is that the donuts, if we don't catch them, even if we do catch them, it doesn't really matter. They're getting hidden, but their position, let me put a show block in here instead, they all kind of start collecting at the bottom of the screen here. So they're still there. We were hiding them, but they're still showing up. So I'm getting all kinds of sound effects and stuff that I don't want. So here's where that last block of code comes in for our clones. And that's the delete this clone block. So a couple of the things that we've already determined are that when Scratch the cat catches the donut, we're hiding it for right now. But what we really want it to do is actually remove that block completely. So I'm going to get rid of our hide block and just delete this clone. And same thing for if it hits the bottom of the screen. So rather than just kind of using that trick and just hiding it, making it invisible, we're actually removing that donut completely. So now, if I play the game, we'll get our same pattern of events. But now those sounds no longer repeat, because since that clone is deleted, its logic stops. It's done. It's gone. It's removed from the game completely. Our high score still goes up because that logic happens before we've deleted the clone. Now we have an actual game that we can play. Okay, the next step. Obviously, we've mentioned right now, game isn't very much fun because number one, we can't lose. There's no way to lose. And number two, there's no way to really win. There's no challenge to it, as Bob mentioned. It just kind of is very simple, very meaningless, essentially. So we're going to put in a win-lose condition right now. So the first thing we're going to do is we're going to create lives for Scratch the Cat. Scratch the Cat, if he misses a donut, it will remove a life from him. Just like Mario has a certain number of lives when you play, or Pac-Man, you get a certain number of rounds that you can play. Scratch the Cat's going to have lives that we can use to determine if you've lost the game. And the easiest way to do that, in my opinion, obviously, again, I'm going to reiterate, there's multiple ways to do this. But for me, the easiest way is just to make a variable. We're keeping track of the current score and the high score. So we may as well keep track of lives as well. And I'm going to say game lives. And again, like we talked about when we made our variables last time, I'm going to do it for all the sprites, because Scratch is going to need to know how many lives he has, and the donuts are going to need to be able to make changes to the number of lives that he has. So if he misses a donut, we need to be able to subtract that from him. So the first thing that we're going to do is set up our level. And again, we've set the current score here to 0. So we're also going to set our lives here. And, he's a cat, so why not 9? So Scratch the Cat is going to have 9 lives. And that will be set as soon as the game starts. So every time we start the game, no matter what other logic we've put in, it's going to get reset to 9 lives because this little block is going to run. Okay. And we've already got the logic for if he misses the donut here in the donut section. So we can change our game lives by -1. He loses a life when he misses a donut. So just let's test that. Let's let a couple donuts fall to the ground. We should slowly start seeing those tick away as they get squawked out. 4, 3, 2, 1. Okay, so our counter is working, but if you're following along, you may already see the problem that's going to happen. If we start the game, it resets to 9, but it doesn't do anything right now. So if we get 9 donuts to fall, or actually 10 donuts to fall, you'll quickly start to see that our variables can actually go into negative numbers. Okay, so our game lives here, we'll move it over to the right so we can separate the score from the lives, but you can see it's going negative now. Okay, so here's where we need to put in our logic for what actually happens when the game ends, when we hit 0 lives. And the way we're going to do that is we're going to add a script to our stage here. We're already checking some things. We're already doing some forever blocks to check some other stuff. And again, the only reason we have 2 separate forever blocks is because this happens all the time, but this one needs to wait 1 second in between. Okay, so anything like checking whether or not we've lost the game, we don't want it to wait 1 second in between the time that it checks, because otherwise we may end up with a situation where we do lose lives and we see that negative number. So we want this block where it's happening all the time. There's no delay in it. So I'm just going to say, if something happens, then it's game over. And in this case, it's kind of easy to set that, which is if our game lives drops below, I'll say 1, because in this case 0 is technically when the game ends. Okay, and this gets kind of tricky sometimes. You may run into situations where you have to decide whether your condition is actually something like, and actually we'll do this on purpose. Your first instinct might be to check if our game lives equals 0. Okay, that's pretty reasonable, I think. If our number of lives hits 0, then we do something. We end the game, we say game over, we do whatever. But the problem is I know this just because I know kind of where we're heading, but you probably discover this later on. Yeah, exactly, Bob. Bob said, it seems that the essence of good software design is to anticipate all the possible outcomes when a conditional event occurs in all the different possible ways. And you're absolutely right. What's going to happen if we use this game lives equals 0 is that if we do continue on with kind of what I was talking about initially, and our game speeds up, the donuts fall faster and faster and faster, you may actually get into a situation where the game is going so quickly, or the donuts are dropping so quickly, that you catch 2 of them at the same time, or you miss 2 of them at the same time, and our lives go from 2 to -5 or -3 or -1 immediately, and they never actually hit 0. It just, you lose multiples at the same time, and you never actually hit that number 0. So this condition only is satisfied. It only happens if it's exactly equal to 0. If we've exactly managed to hit the point where our lives, hit 0, we missed or caught just the right amount. Whereas this condition that I've set up handles the 0 condition and anything below it. Okay, because as long as it's less than 1, it's -1 is less than 1, -5 is less than 1, 0 is less than 1. Every single one of those conditions is less than 1. So we know for certain that no matter what happens, once we get past that point, this condition will fire. This will happen. Whatever blocks we put in here, those are going to happen. Okay, so what I'm going to do is I'm going to add in a sprite just to test this, and I'm going to put a giant X on the screen. Okay, so we got this block here. And I'm going to say if game lives is less than 1, then we're going to make this X show up on the screen. Okay, and I'm going to put this X at 0, 0. And I'm going to make it real big so it covers the entire screen. %, let's go 400. Let's turn this up to 11. Okay, so now we have a giant X that is on the screen. Right now, it's always going to be there because we haven't actually put in any logic or anything. But I'm going to put some logic in here so that when it starts, we hide that X so that at least while we're playing the game, it doesn't show up. Okay. If you have, okay, Miguel says, if you have 2 when clicked commands in the same page, how does the system determine which one is the active one? So it doesn't. Both happen. There is no active one. And actually, if we look at our not scratch the cat. If we look at our stage block and we run it, you'll notice both of them are highlighted in yellow. That's because both of them are actively running at the same time. The only time there's ever a kind of a battle for 2 things happening at the same time is if you're like setting a variable value or you're actually changing something in game, you're making a change in your logic, and that just happens in order. Whatever order the game hits them in, that's when it happens. So if you have 2 loops going at the same time and the order is different, you might see that value switching back and forth as they each kind of make the change. But that's just going to happen in the order that the game hits that block in. Okay, so I'm going to put game over as the name. So like we talked about when we renamed Scratch the Cat, I'm going to click on this little letter I and just rename this to game over. And you might notice a problem right away. We've hidden our block, and our logic here that checks if our game lives is less than 1 shows in the stage. But there's no blocks here that say, show the X, show game over, or show whatever. And we could potentially create a clone of game over and then set some logic to make that clone happen. But that means that we then have 2. Sorry, Miguel said, so conceivably you can add an infinite number of commands. Conceivably, yes. Practically, no. So going back to what we talked about, where the more loops you have going on at the same time, the slower the game gets. It will get really, really slow. So if you have a bunch of when flag click blocks that are all running at the same time, it will definitely slow the game down. So you, in most cases, want to put them all in one when flag clicked block so that it's checking all those conditions, in the same loop. And again, the only reason that we have 2 loops here is because of this wait block. I need the donut creation to take a pause of a certain amount of time before each donut is created, whereas these, I don't want them to pause. We can't share this loop block because we have to have this wait in here somewhere. If I added this in here, then it would also check the high score only once a second. And it's possible for our high score to change it within that time. So that's why we don't have that set up that way. But here's where we introduce messages. And messages basically just allow different objects in our game to communicate with each other in instances where they normally would not be able to communicate with each other. Okay, and messages are found in the events block, and they're down here at the bottom, and essentially all they are custom events. So here we've got our events tab, and we've already talked about the flag clicked. We talked about when you click a key on the keyboard. There's a block here for when you click somewhere on the stage, you can have certain, logic happen. You can have logic happen when our backdrop changes to a different scene or a different graphic or something like that. But messages are essentially custom blocks. And just like our clone block, you have to broadcast a message first. You have to create an action first before you can actually start to follow along with that logic. Okay? And what I mean by that is a message is just like it sounds. I think the name is actually really, really appropriate, because if you kind of picture the message in real life, imagine that each of our sprites or each of our objects is a person standing in a room or standing out in a field, okay? And we're going to start a race, but everybody's all across different areas of the field. They're not going to know when I'm ready to start, and I'm not going to know when they're ready to start. But if I yelled 3, 2, 1, go, everybody can hear me yell go, and they can tell, it's time to start, because when Derek yells go, start. That's when you go. That's when that's when you do whatever it is you were supposed to do for this event or this race or whatever. And these messages work exactly the same way. So I can tell our backdrop here that when my game lives drop below 0, I can broadcast a message, and by default it'll just say message 1, but just like with everything else, we can rename it. So I'm going to name it game over. My lives drop below 1, then I want to shout game over to every single object in my project. Every single one of these guys is going to quote unquote hear our game shout game over. Okay, and once that shout happens, once that message gets broadcast, I can then take some steps with this. I can take this block and have some logic happen when game over happens. Okay, and in this case, I'm going to put some simple logic in. Again, we can make some other changes, but I can tell it to stop all the other scripts in this sprite. I can tell my donut that when I get that message, game over, to delete this clone, and all my donuts will delete. And then finally, when game over is clicked, when we get that game over message, I can show my game over arrow. Does that make sense to everyone? So now if I start this, you'll see it happen that when my game lives drop below 1, this message, game over, is going to get sent out. And when that message gets sent out, these items here are going to follow whatever steps we have here when that message happens. So this broadcasts game over, and then these receive game over. It's almost like an input and an output, kind of like a stereo system even. When this happens, we broadcast the message. We say, hey, the game's over. And then all these guys have special logic that happens when they hear that game over message. So now if I play my game, what should happen is that when I hit 0 or lower lives, Scratch the Cat stops completely because we've stopped all the other scripts. And so just to clarify, we have a couple different options here. We have an all. So this stops the entire game. This stops every script. This stops this script, which literally means this game over script. And then this one means other scripts in the sprite, which would be this. And if we had any other blocks anywhere else, that would stop those. Our donut clones get deleted. Every single donut clone should get deleted. And then when I receive game over, we show that giant X. Okay, and this might not be perfect. I actually, I'm not 100% positive if this will work the way that I intend it to, but we're going to try it. So, oh, I'm catching donuts. I'm going to miss all these. Okay, all of our donuts got deleted. Scratch the Cat is gone. He can't move. If I hit the arrow keys, nothing happens. and my game lives are 0. Okay, does that make sense? If you're able to see it, I don't know if it's showing up that well on the Hangout, but something that you might see is that our donuts are still appearing. You might see flashes of donuts up at the top of the screen. Okay, and that's because, again, if you click through each of these and you look at our code, our stage has code that's still highlighted in yellow. So this is still happening. This is still going. All this logic is still happening. So we also need to add in a when I receive game over, stop other scripts in this stage here too. And that'll stop those from running. Okay. So does that make sense? Do the messages make sense? We're literally broadcasting a message, and then we can individually tell each of the items or each of the characters or each of the objects in our game to perform a certain set of instructions when that happens. Okay, so we'll start again, just test it really quick to make sure our game over script on the stage works the way that we intended it. Two, 1, 0, game over. So nothing's highlighted in yellow anymore because this kicked in. Nothing's highlighted in yellow here. Nothing's highlighted in yellow here. And nothing's highlighted in yellow here. So officially our game is now stopped. Okay, so currently we have not really a win condition. It's kind of like Tetris. It just goes on forever. So to Bob's original point, we can keep catching these donuts and keep getting our high score. And then if we lose, our game stops. We get a giant X to signal game over, and then it's done. Seems that messaging is a way to get one code block to control as many code blocks as you want. Kind of. It can be used for that. It's more of the way that I like to describe it is a custom event system. So Scratch has events that they've already programmed in, like when you click the flag, when you press the space bar, when you do whatever. The messages are really a way for you to choose when something happens. So you can create your own conditions for other objects. So yes, while it does allow you to control as many code blocks as you want, it also lets you control as many sprites as you want and so to selectively do so. So we could potentially have logic that happens, when we hit a custom event. And actually, our homework for next time can be, if people want to play around with this, I would really suggest for you to try to create like an evil donut or a rotten donut. Duplicate our donut here, paint some green mold or something on it, and then that one can remove a point from the high score. And that's a custom event. When I catch a crusty donut or whatever, do something else. And maybe we have because that logic wouldn't really do much, but you could have like a message where something shows up on the screen that says, be careful about catching moldy donuts. They hurt you. They don't help you. And so we would create a new sprite for that little message, write that out on the screen, and then our moldy donut can communicate with that message to pop up on the screen, wait 3 seconds, and then hide it. So again, it's more of a custom event rather than just a way to arbitrarily control code blocks. Derek, were you manually moving the cat, or was it the programming that moved it in this last event? What do you mean by the cat? It only moves when I click the arrow keys. Oh, yeah. I'm clicking the arrow keys. So I'm specifically moving Scratch the Cat left and right now to, in this case, avoid the donut since we were testing our game over. Is that what you were asking? Yes, okay. Yeah, so I'm using my arrow keys to control scratch the cat. Okay. And that logic, just in case you needed to see it again, is under scratch the cat. And that's just the if left arrow key is pressed, move him to the left. If right arrow key is pressed, move him to the right. And again, we can change our speed here. So if we want him to move slower or faster, we can do that. So now he moves a little bit more slowly. A little too slow for me though, so I'm going to set him back. Okay, so we've got about 10 minutes left. So what I'm going to do now is kind of get you guys started on Bob's point, which is essentially right now this game isn't really much fun. And more importantly, in the interest of good game design, the way the game is currently set up, I can just sweep this left and right from end to end, and I will never lose. The timing of the donuts as it is right now is slow enough to where it doesn't even take a full second for the donuts to kind of fall below where scratch then catch them. So I could potentially just go left and right the entire game and I would never lose. Okay, so here's where we can kind of do some fun stuff. We don't necessarily need to use events for this, but we can. It depends on how you want to do this. So I'm going to set up an event, but your homework is to kind of try to create a custom version of this. Don't try to duplicate what we're doing exactly, but try to do a custom version of this. So what I'm going to do is I'm going to create a variable for the speed of the donuts, and I'm just going to call it donut speed. Okay? And the donut speed is basically just going to be, sorry, I'm going to delete this extra donut since we don't have the moldy donut. But the speed is essentially going to be this Y position. Right now, our speed changes by -1. The donut falls by -1 pixels every time this loop goes around. Okay? So my donut speed, when I start the game, I'm going to put donut speed and set it to 0.25. Okay, we can set it lower than that if we want to. I think that's a good slow speed to start the game at. Whoops, I didn't mean to do that. It's a good slow speed. It's a quarter of the speed that we're hitting right now. But it gives the player enough time to kind of figure out what's going on. Unfortunately, we don't have any directions for how this game works. So without putting up multiple messages and kind of cluttering up the screen to do it, maybe if we wanted to, we could put like a little arrow that says left here with a arrow key, a picture of the arrow key on our keyboard or something. But I think the game is simple enough that people can kind of figure it out. So I'm going to set my donut speed to 0.25, and then I'm going to replace, oh, sorry, not 0.25, -0.25. That would actually be really funny. The donuts would start to float up from nowhere, so we don't want to do that. But then I want to change my donut, so instead of using this Y value, we're going to have it use our donut speed. Okay, so the only change I made is I changed this from -1, where it was, where the donuts fall at this speed. And I'm replacing that with donut speed. And you'll notice that I can actually do that while the game is running, and it slows down really, really nicely. We get a nice slow crawl from our donuts. Okay. And actually, that might be too slow, or we might need to change the timer. So here, maybe we can also set a variable for the timer that gets shorter and shorter so that more donuts fall as we get on. For right now, it's okay. We won't change it just yet. But our donut speed is set here. So now what I can do is in my stage, I can use, again, more logic blocks here that say if the current score is above a certain score, then set the high score. I'm going to say every 10 donuts we catch, the game speeds up. So every time we hit 10 donuts, the game speeds up. Okay. So again, if something happens, then change donut speed by negative 0.25. So in this case, when we hit 10 donuts, change our donut speed by negative 0.25. Okay, and the way that happens again is that it's just going to add. So then our next thing should be 0.5, and then negative 0.5, then negative 0.75, then negative 1, then negative 1. So slowly those donuts are going to start to speed up as we go. And just to kind of get this working, or to kind of show this working, I'm going to put this logic in here so that I can manually change the speed by just tapping the space bar. And this is, again, just to test to make sure that the rest of our logic is working and that our variable works the way that we want it to work. So our donuts are falling. I can press space bar, and that should speed them up by 0.25, 0.25, 0.25. And every time I tap the space bar, tap, 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 they just get faster and faster and faster. Okay, so tap, 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 tap. Okay, so now we know that that logic works. They do actually speed up when that code block happens. So I'm going to remove the spacebar, and now we need to figure out what our actual condition is. And this this might get into some math that people aren't used to. So again, there's multiple ways to do this. I just find that this is probably the easiest way to do it. But we need to check to see if our current score is a multiple of 10. Okay, because I want to change that score every 10 donuts, or every time we hit 10 donuts. We've only got a couple seconds left. So one of the things that we can do is we can divide. We can say if our current score divided by 10 is less than 10. Okay. So if our high score, so right now, I'll just use the current high score that's on there. If we divide this by 10, we'll get 3.1. Okay. So that technically won't work, but we could check if the high score is equal to 1, 2, 3, 4, 5. So we can make a bunch of different blocks that say if high score divided by 10 equals 1, change the donut speed by negative 2.5. If high score is 2, you could use variables too. So you can raise a variable 1, 2, 3, 4, 5 each time as the score goes. But the easiest way to do it, in my opinion, is to use this little guy right here. And hopefully you guys can see that. But this operator here, it shows just the word mod. And mod is kind of a weird operator, but essentially what it means is the remainder. Mod stands for modulo. And if you're pretty comfortable with division, then remainders typically make sense. But basically, if we look at our high score here right now, if we divide our high score by 10, we technically get 3 10s with 1 left over. So mod is a variable that gives you that remainder. Okay, so if we did a mod, and in this case, I'll type in our actual stuff. So if our current score mod or divided by 10, what that means is current score divided by 10 remainder. So if 31 divided by 10 is 30 with a remainder of 1. So in this case, this equals 1, not 3, because 3 is the actual divided number, but only the remainder. Okay, so what we're actually looking for is this value here, this current score modulo 10. Every time it actually is a multiple of 10, the remainder should be 0. Does that make sense to everybody? So if our high score is 30, 30 divided by 10 gives us a remainder of 0. 31 divided by 10 gives us a remainder of 1. 32 gives us a remainder of 2. 37 gives us a remainder of 7. 47 gives us a remainder of 7. So essentially the mod of all those numbers is just going to keep going. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Because we're only focused on the remainder. So only numbers that are multiples of 10 will trigger that. So then we can compare that. We can say if our modulo is equal to 0, then change the donut speed. So now, oh, whoops. Oh, interesting side effect. So if you're paying attention, we're checking if our current score is evenly divisible by 10. So if the remainder is 0. Well, when we start the game, our score is 0. So the remainder of that is 0. So this is actually happening over and over and over and over and over again. So we need to make sure we put in an extra condition here, which is just that our score is not 0. So I'm going to use this AND block. I've dragged out this big AND block here, and that just lets us do multiple conditions. It checks for the first part and the second part. So I'm going to check that current score modulo 10 is 0, and our current score is greater than 0. So that way it doesn't happen right when we start the game. Okay, this might be a little bit confusing. We're going to go over that stuff again next week as well. But if we play the game now, the donuts should fall. I'll be able to catch these all at the same time as soon as they go. And then they should start to speed up. So while we're waiting for those to fall down to the bottom, we're pretty much out of time. So I just want to kind of recap on the homework for next week. The homework is to figure out how to fix this issue of all these donuts clumping up on the screen. Our wait time is only 1 second. So with the donuts falling that slowly, that we kind of hit that really fast. That worked pretty quickly. And again, you'll know there's a problem here that we will address next week. But right now, when the score hits one of those even numbers, again, we're constantly checking and raising the score. So we'll need to fix that next week. So that's our messages and our clones. Again, I would highly, highly recommend that you guys continue to play with this. You have kind of 2 options for homework, which is 1, to try and fix the clumping issue, which, again, the hint is that it has to do with this wait time here. And then the second one is to try and create a rotten donut that when we accidentally catch that, it lowers our current score. Okay? So those are your 2 options for homework, and then we'll touch on those next time. Okay, I'm going to turn it over to Bob then. If anybody has any questions, I'll still be around, so feel free to put messages or questions in the chat box.
Yeah, thanks, Derek. I had a question for actually Miguel and Fernando and Lee. We've now been through 3 sessions, and Derek, I think, has done a great job of teaching Scratch to us sort of mentor type people, adults. I'm wondering how you guys feel about how your students are going to react to this material. Do you think this material is doable by them, or is it really hard? Is it too easy? And then I guess the other side of that question would be for Derek. What's this been like for Derek, for some of the students you've worked with in Gilbert? I'm curious what the Yuma folks think first. And I don't want to spend too much time on it because I know we're kind of over the time. But I was just curious how you feel about it at this point in terms of where we're at and how that's going to work for Yuma students at the Dev Day Yuma event.
Can you hear me now?
Yes.
Oh, okay. Yeah, this material is really interesting, and I'm pretty sure my students will be engaged with this one. And they will like it.
Cool. Okay. Great.
Yeah.
Miguel or Lee, did you have any thoughts on that?
Well, can you hear me? This is
Yes.
Lee. Okay,
Hi, Lee.
yeah. Okay. So yeah, I have no experience for high school students. Well, for college students, of course, they should have no problem to
Yeah.
catch up this. So yeah, the logic is straightforward, but they need time to do some hands-on work, I think.
Yeah.
Yeah.
Okay. Miguel, did you have any thoughts?
Is he still muted, maybe, or just?
I don't think he's muted.
Oh, there we go. He said the students may be engaged, but I'm wondering if they'll be able to actually use it properly.
Yeah.
So I would say from my experience working with, so we now this past year had our first junior high class participate in the event. And I've done a couple mini Spark sessions for junior high classes around here in Gilbert. And I think Lee is kind of, she's right in that initially you kind of have to go through something like this with them, which I know you guys have some, education time planned out at the start of the event. My experience has been that at least 50% of the students at some point before the end of the education session just kind of veer off into their own playground. They feel comfortable with it. They kind of need that primer right up front.
Yeah.
But like Lee said, the logic is actually pretty simple. Once they start to play around with it and they see how the code blocks work, they're just gonna veer off and start doing their own thing. And then right around that time, like as you see the majority of students start to veer off, that's really when you're gonna want to just be there to start answering questions for them, because they're going to have questions on, what certain blocks do, or what, how to change certain things, or what's the proper way to format a logic block. Miguel said, how far would they go to the actual day of the event? Will they be expected to go as far as we will go in the 6 weeks? Well, I think it's a little bit different because you guys are doing the exercises, so they'll have at least a baseline to start from. They won't be creating everything from scratch the way that we did on here, no pun intended. But they will. I think they'll get farther than we have gotten in this session. It'll be, and when I say farther, it'll just be different. They may not go into the messaging blocks, or they may not go into cloning. It really depends on what the exercises are. Like, I know for one of the exercises was that lunar lander. That exercise doesn't use cloning at all unless they add some kind of power-ups or some kind of special condition that changes it from the base exercise. The base exercise itself just uses the regular logic blocks, so they won't use those. Yeah. So I think our training here is more in depth. We go deeper, but they'll definitely go wider. They'll go all through it. Who is going to determine that? What, the exercises, or who's going to determine? Can you clarify that, Miguel? Sorry, Miguel is writing in the scope and sequence. I would say, I think Bob or the planning team, I think you guys have kind of already figured that out.
Well, actually, no, we haven't figured it completely out. But I've been exploring some possible exercises, Miguel, that we could use to, or at least adapt to the event. And you know, as I get further along with those, I'll share them with you. I'll share them with all the mentors, in fact, to kind of show you what we're thinking about. And you know, I'm also kind of consulting with Derek on that a little bit, but there's some good stuff that's already out there, so we don't really need to totally reinvent the wheel. But some of these exercises that we found, we might have to adapt them a little bit because the answers are posted online, or at least example solutions are posted online, and I don't want the students just looking that up, you know. So we've got a little work to do to sort out what's the right difficulty level and that sort of thing. But we have a source of exercises identified, and it's just a matter of picking out some good candidates and then getting consensus on them. But a couple things to what Derek talked about. Yes, we've been sort of working on what should be the agenda at the event in terms of orientation for students. And originally we had 45 minutes scheduled to orient the students to Scratch, and I recently increased that to an hour and 45 minutes with a 15-minute break in the middle. And the idea is that and it speaks to exactly what Derek was saying, the idea is that we'll take a look at how they're doing. We'll poll them or ask them how they're catching on to Scratch, you know, kind of at that midpoint, and if they're kind of catching on and starting to move into their own exercises, then we'll just end the orientation and let them take off and start working on the exercises. And the other thing that we're working on doing is sending out some info to students to help them get started with Scratch before the event. We won't be able to assume that all the students are going to pick up on it before the event, but we want to give them that opportunity, and hopefully that'll help the overall set of participants, you know, get a little head start on Scratch.
Yeah, and I would agree. Miguel wrote, it seems as if it would be best for them to start a little earlier.
Yeah.
I think in your case, because your event is not a competition, it absolutely is the right call to send them out information and even tutorials or you know, anything that you can send out to them in advance, because then the students who are really interested in the coding and stuff, they definitely, I mean, they will pick it up and they will start going. They will come to the event ready to blow all your exercises out of the water. And at that point, you know, you can challenge them to you know, come up with their own you know, like I was saying with the lunar lander thing. If they figure out all those solutions during the time of the event, have them make up their own extensions, have them figure out ways to make that, you know, that activity even better, and they'll, trust me, they will figure out a way to challenge themselves, and then they'll try to figure it out. Yeah.
So look for that sort of material coming from us here pretty soon, folks.
Yeah. I was going to mention, sorry to cut you off, Bob. If everybody can still see my screen, on the right-hand side here, there's a little question block. It's kind of hard to see, but it's right on the top right-hand corner. The Scratch team has already made some tutorials on really, I mean, they're not very in-depth, but they're very basic ways to use all the different blocks. And most importantly for the mentors, because you probably will get questions about like what these different blocks do. And if we've never used them before, that might be difficult. But every single one of the blocks has, you know, a pretty in-depth description of exactly what that block does. So if students come to you with questions on that, you can always just pull up that help file and you know, kind of let them go to town on that too.
Yeah. Yeah, here's Miguel commenting, we're planning on taking approximately 28 students, and that's from Miguel's high school, which is San Luis High School down in the South County. And San Luis is noted for its math and science emphasis. But it says with that many, I'm not sure all 28 will be up to the task if they know previously what's involved. It could help them decide by themselves if this is really for them. And that's actually one of the goals of this event, is to help students see, to determine for themselves, hey, is this something I'm really interested in pursuing, either as a hobby or as a career? Either way, we want to give them an opportunity to find out. And if it is for them, then we hope to be able to channel them, or to direct them to follow on things they can do to pursue software as an area of interest or as a potential career path. So that is a specific objective that we have for this event, is to help students determine, is this an area of interest to me, and if it is, where can I go from here?
I would just caution against one thing, or kind of, I hesitate to agree with kind of the sentiment of letting them choose if they, I don't know, Miguel, if your intent is to say if they want to attend the event, or if they want to, necessarily like pursue programming as a career. But I would just caution, because number one, every single career is going to require some kind of programming in the very near future. So in terms of, them deciding whether or not this is for them, it's going to have to be for them. What you may need, to let them decide is whether the activities are something that they're interested in, because coding by itself can be applied to anything. It's not one of those things that like, oh, you have to make apps, or you have to make games, or you have to do this exercise or this exercise. Maybe they're not interested in a lunar lander game, but maybe they're really big into cars, and maybe their dream is to be a mechanic when they grow up. Well, then maybe the best exercise for them is not to figure out how to get the lunar lander to land, but it's maybe to make something on their own that lets somebody fix a car, or something like that. So I would just caution. I'm not saying everybody in every single profession is ultimately going to end up being a programmer or anything like that. But I think a lot of kids, when they first approach it and they see kind of coding that's involved, they may stray away from that, and that they're doing themselves a disservice that they may not even realize they're doing this early in the game.
Yeah. It could have that effect, but maybe my hope is actually that it might have the opposite effect on at least some students, where they won't be so afraid of software or programming or whatever. I mean, even if you're going to make jewelry for a living, and then you're going to have a little website that shows what you make, there's probably going to be a point where you're going to want to put a little line of HTML code in there to make your website do something. And if it does nothing but help them not be afraid to do something like that, then that's pretty helpful, I think.
Yeah.
So we hope that it'll have more of that effect, rather than scaring people off to say, oh, this is hard, I got to find something that stays away from this. That could be a losing proposition, I think.
Yeah. Well, and on top of that, I think that a lot of, not just students or kids, but just people in general, there's the quote, it's something like the sufficiently advanced form of technology is indistinguishable from magic for those that don't understand how it works, and that's the kind of thing. If they're looking at, what am I trying to say here? If they're looking at something like code, where they're afraid of computers in general, or they don't understand how computers work, like even just understanding the basic logic and the basic code will help them in their general computing experience, even if they don't decide to go into coding. Miguel said, just to clarify, the 28 are not all from the group that is taking calculus. Miguel, what percentage of what percentage of the students are like calculus level students and which ones aren't? And are we talking about like polar opposites, where half the group is like really, really into calculus and is great at it, and then the other half is struggling with basic math? Yeah, from the group of 28.
Yeah, he says Fernando may be better able to answer that. Any thoughts, Fernando?
Hold on. Calculus minimum, let's say 5, 6, maximum 10.
From the calculus group. So, and then the other students are like beginners? Are they
No,
trained?
but I was checking with the rest of the students, and some of them, well, majority of them practice some kind of coding, in another sessions. Not specifically this one, but other ones.
Okay. So, but they're familiar with the logic, with
Yeah,
branching
exactly,
and stuff like that. Okay.
Yeah.
Yeah. I mean, I would highly recommend then doing, your exercises that you guys have planned, and then letting the students come up with their own extensions of that. Because, especially if you have 6+ students that are, not only into coding, but also calculus, there's tons of stuff in Scratch. See if I can pull it up again. There's tons of stuff in Scratch where that math will definitely come in handy. I've seen kids make with like these sound blocks here. I didn't really cover these in the sound section, but you can have notes that play, that they can mathematically write music and stuff using these little note blocks and changing instruments. And I mean, there's tons of stuff that they can do with that.
Yeah. Yeah, it seems like Scratch, it obviously it's sort of built to appeal to the lowest common denominator, which according to Scratch itself is 8-year-olds, but it also seems like you could take it pretty far.
Yeah, well, and that's what part of what we're going to talk about next week is like these more blocks. You can even write your own functions and your own extensions for Scratch. They have Lego makes I forget what it's called. It's not Mindstorms, but they make a kit that you can actually plug a USB cable into your computer, and it interfaces with Scratch to control their little motor. I forget what it's called though. But it's literally a kit. It's a robotics kit that you program the robot in Scratch, and they have all kinds of blocks that you can add. Maybe even we can see some of the extensions. Yeah, we do. That's what it is. And like there's hardware boards that you can plug into it, like a Raspberry Pi. This is it's called a Pico board, but it's specifically like a kind of a, like, what do I want to call it? Like a simplified Raspberry Pi board, and you can control electronics and sensors and stuff with it. So,
Wow. So you can build a Scratch robot, basically.
Yeah, absolutely. And they even have part of the WeDo kit is that it can take input from a webcam. So there's like a game that you can play where you can make like, bubbles come up on a webcam, and you can kind of like hit them with your hands. You guys can't even see what I'm doing here. Okay, here you go. So like imagine bubbles are coming up, kind of the opposite of our game. Instead of donuts coming from the top, bubbles come up from the bottom of the screen, and you can literally like swipe at them and they pop. And I mean, there's all kinds of stuff you can do with it.
Yeah, that's great.
Would it be appropriate to sell this as a Lego approach to programming? It might be easier for potential future participants to have an idea of what they're going to do. That depends on how you define that Lego approach thing, because I think that if you just frame it as Legos and make it seem kind of basic like that, that it will turn away advanced students. And, as Bob mentioned, and as we're kind of going to show next week, it is a full featured programming language. So just because it seems kind of cartoony and simple, I don't want that to turn off students that might actually do some really cool stuff. Actually, one of the things that I do for Spark right out the gate, let's see if we can go back here. If I pull up,
Yeah, if I might interject a little bit, it seems to me that where software goes beyond the sort of the process of building something with Legos is the conditional branching sort of things. Building Legos, you're going to just put together a bunch of blocks and you're going to end up with a structure of some sort. But with software, you have the power to react to situations or to events through conditional branching or just branching and looping and that sort of thing that make it far more powerful in a sense than just a building block. But maybe a building block's sort of analogy might be reasonable if you're trying to appeal to beginners or people who you don't think are really going to go very far with programming. But I want to be cautious about that for the reasons that Derek just mentioned.
Yeah, well, and I like, Lego is something that everybody knows, everybody understands,
Yes.
and really this is kind of like snapping Legos together. So I don't have an issue, or I wouldn't shy away from using that because it's a great analogy. As long as, what I was going to say is I always show students this project. It's Super Mario Kart, and this one, for whatever reason, I mean, really, like, because every student that I know has played Mario Kart at some point. And so if you look at it, like, this is Scratch. I'm playing something in Scratch, and it's Super Mario Kart from the Super Nintendo. So while it seems like everything in Scratch is really basic, I mean, look at those blocks.
Yeah.
And there's, each of the carts has different logic that they use. So yeah, it's basic, it's Lego blocks, but you can do some crazy complex stuff up to and including recreating Super Mario Kart from the Super Nintendo. So as long as they know the possibilities, I guess that's my point. The Lego approach is fine. That's a great way to position it to people, and especially students, but just make sure that they don't, make sure that they're not looking at how simple it is and dismissing it because of its simplicity. It's simple in the outs. It's one of those things that takes 10 minutes to learn, but 10 years to become an expert in, kind of sort of a thing.
Yeah.
It's definitely one of those, and it like even this project that I have up on the screen, it's using those messages. They've got custom blocks in here. They've got clones set up. I mean, they're really using everything.
Yeah.
Yeah. And Miguel, I mean, that's kind of your responsibility, is to make sure that the students that have no programming knowledge are aware of that simplicity, and that the students that do have programming knowledge aren't turned off by it. We just this year did our first advanced level event, and that was one of the things that was, I think, most difficult for us, is we had a lot of students that enjoyed the Scratch event a lot because it was so easy and they didn't have any programming experience, and they wanted to see what real code looked like. But then it was, Lee said, the language you're using is simple, friendly. Yeah, I agree.
Yep. Yeah, and it seems to me what Scratch does is that it takes those programming concepts or the thinking concepts and makes the implementation easy enough to where you can focus on thinking about
Agreed.
how you want to create your game, rather than putting a focus on, gee, do I have the language syntax correct? So I think that's the real advantage of Scratch for beginners and young folks, and maybe old folks too. I mean,
I always tell people that Scratch is a full programming language that's just saving you a lot of typing.
Yeah.
That's really it. Don't dismiss it because of how simple it looks. It's a full language.
Yeah. Okay.
There you go. Good learning opportunity then.
Okay. Good. Okay. Well, if anybody else has any questions, now would be the time, because I think we've gone way over the time. So my apologies for that, but I really appreciate you sticking that out and having this discussion. I think it's pretty useful, and I hope it's helpful in helping you sort of figure out how to relate to the students about this, and hopefully that'll make it just that much better of an event. after next week, next week we've got more topical material to talk about, but after next week we'll be talking about the exercises themselves. And so by then we'll have already kind of shared with you what we're looking to do in terms of exercises, and you'll have had a chance to give some feedback on that, and hopefully we'll be able to get into them a little bit and understand how to make them work and how to get students to make them work. So that's kind of what I see happening going forward.
Yeah, and Miguel and Fernando, I would also recommend, because it sounds like you guys are in a little bit more of a unique situation. You guys should try finding exercises that you can kind of market specifically to your group. Bob was really insistent. The exercises that we've kind of found so far have like a easy, medium, hard difficulty. You may want to work with him, or even just together on your own, to find advanced scratch exercises, because they definitely exist.
Yes.
Okay.
So.
All right. Well, then I guess I'll see you guys. If anybody else has any questions, I can hang around. But otherwise, I'll see you guys next week, and we'll even talk about some of that advanced stuff. So awesome.
Okay.
Great.
Thank you guys.
Thanks, everybody.
Have a nice week.
Yeah. You
Thanks,
too.
everyone.
Bye.
See you guys next week. Bye.
Derek, can you hang on a second?
Yeah.
Okay.